Hey everybody, welcome back. So last episode we set up the programmable stages for the graphics pipeline. Today we're going to set up the fixed function stages. So that's going to include things like the input assembler, the rasterization, and the color blending stages. So let's get right into it. This one's going to be it's going to feel kind of silly, but it's all necessary. So first off, we're going to do a tiny bit of work for the Vertex input. So this is just so the stages know how to read the Vertex data that we hard-coded, but this will get expanded upon when we start setting up the input buffer. So within the CreateGraphics pipeline function, we're going to set up a new CreateInfo for the Vertex input. So just underneath the shader stages right here, it's going to be a VK pipeline Vertex input state CreateInfo. There we go. Let's call it Vertex input info. Alright, there we go. And now we have to fill out everything for it. So first off, like everything else, we need to have an S type. And in this case, it's going to be VK structure type pipeline Vertex input. There we go. Vertex input state CreateInfo. More lengthy S types. So we're going to set. It has a count for it. It's, Vertex input info dot Vertex binding description count. And we're going to set this to 0 because we're not passing in any data yet. And we also need to fill out Vertex attribute description count. And once again, 0. There's no data coming in. You know what? Let me close this up right here so we know this is all part of the same CreateInfo. So that covers everything for the Vertex input. Now we need to get to the input assembler. So once again, another CreateInfo. That's basically all this episode is going to be. It's going to be setting up lots of CreateInfos for different structures. So VK pipeline, if I could spell, pipeline, input, assembly, state CreateInfo. Call it input assembly. There we are. Alright, and now we can start filling this out. So, there we go. And we need the S type again. Did I spell it wrong? Assembly. Nope, looks okay to me. There we go. And in this case, the input assembly is going to have a VK structure type, and it's pipeline input assembly create info. I must have spelled something wrong. Oh, sorry. It's pipeline input assembly state create info. There we are. So now we need to fill out another bit of data for it. It's going to be input assembly topology. There we go. And so for this one, the data that's in the input assembler describes what should be drawn with the vertices that we're going to pass in. So since all the objects we're going to be creating involve triangles, it's going to be a VK primitive topology and triangle list. I'm just going to scroll down to it. There we go. Alright, and we also need input assembly, and it's primitive restart enable. We're going to set this to false. Yeah, and the reason for that, this has to do with changing the order in which the vertices are loaded from the buffer. And we don't really have any reason to do that. We can just process them in the order that they come in. So that covers that. Now we need to set up a CreateInfo for the viewport. Now the viewport data describes how images are transferred from the swap chain image to the frame buffer. So we go ahead and declare a new VK viewport. Call that viewport. And then we need a viewport.x, and we're going to need a viewport.y. I should fill these out one by one. We're going to set both of them to 0.0f. This is the starting point for the viewport span. And ultimately we want this viewport to be the exact same size as the images that are being passed in from the swap chain. So we're just going to have it go from 0 to the width of the swap chain and 0 to the height of the swap chain. So right down here we're going to just do viewport.width, and this is going to set to swap chain extent dot width, and we're going to go ahead and cast that to a float. There we go. And we do the same for the height, so viewport height equals float swap chain extent dot height. There we go. And then we need to pass in a depth, a min and max depth. We're not bothering with depth, so we're going to have min depth be 0. Oh, sorry, got to put an F there because it's a float. And viewport max depth 1. There we go. And now we need to have a CreateInfo for it's a VKRect2D. And this is going to be a scissor rectangle, and that can be thought of like a filter for the viewport. So anything rendered outside of the scissor rectangle is not displayed. So we could block out sections of the viewport using the scissor rectangle. We have no reason to do this, so in this case it's going to be kind of a simple declaration. It's just VKRect2D. Can't get my capitalization right. We'll call it scissor. And like I said, it's pretty simple here. We're just going to say scissor.offset equals, oh, hitting buttons I don't mean to, 0, 0, and scissor.extent equals swap chain extent. So we're making a scissor rectangle that's the same size as the viewport, it's the same size as the swap chain image. It's not going to be cutting off anything. It'll allow us to see the entire viewport, but we still have to declare one. Now, both the viewport and the scissor rectangle are part of a larger object, which is the viewport state. So we need to declare a CreateInfo for this as well, and then assign the previous CreateInfos to it. So we're just going to go ahead and say vk pipeline. Oh, it's vk pipeline viewport state CreateInfo. We'll call it viewport state. There we go. Oh, once again getting some symbols in there I didn't mean to. Ignore that. Okay, so viewport state dot s type. Once again, we need that struct type for it. It's going to be vk structure type, and it is pipeline viewport. There it is. Pipeline viewport state CreateInfo. We're going to do viewport state dot viewport count, which is just going to be 1. We only have one viewport. Viewport state dot p viewports, which is pointers to all of the viewports we created. We only created one. It was this one right here. So we're just going to pass in a reference to viewport. All right. Now we have viewport state dot scissor count. Once again, we only have one of them. And just like before, viewport state dot p scissors, and we pass in a reference to scissor. Alright, so that covers everything there. Time to move on to the rasterizer. So once again, we're going to need another CreateInfo. That's, like I said, all this episode's going to be. It's not exciting, but we need it all. So this is going to be VK pipeline rasterization. There it is, rasterization state CreateInfo. and we'll just call it Rasterizer. Okay, then we need an S-type again. Oh, I spelled it wrong. Rasterizer. Rasterizer. Much better. Oh, dot S-type equals, and this one is going to be VK structure type pipeline rasterization state CreateInfo. There we go. And then this one is just rasterizer, and we need a depth clamp enable, so we're just going to go ahead and set that to false. Once again, it's something we're not using. It has to do with whether or not the fragments that go outside of the accepted range are clamped to the edge of that range. So we're not going to bother with that. And moving on, we have rasterizer, and it's rasterizer discard enable. This is also going to be false. Oh, actually, this shouldn't have been false right here. It should be VK false. There we go. And VK false here as well. And in case you're wondering what rasterizer discard enable is, if it's enabled, the rasterization stage is skipped, which would mean that we wouldn't be getting any output for our graphics pipeline. There are occasions you want to do that. This is certainly not one of them, so we definitely want that to be false. Alright, so next up we need a setting for polygon mode. It's going to be rasterizer dot polygon mode, and we're going to set this to VK polygon mode fill. This determines how the fragments are generated for the vertex geometry that we have. So when you set it to fill, it causes the rasterizer to fill the entire polygon with fragments. And this is its default setting. This is what behavior we want from it. Next up, we need a setting for the rasterizer line width, and we're going to go ahead and set that to 1. And the line width handles how thick the lines are based on the number of fragments. So this would be 1 fragment of thickness. Its default is 1, and anything besides 1 requires changing up a few things, so we're just going to stick to the basics. Alright, so now we need to do rasterizer dot cull mode. And this one's a little bit complicated, so I'm going to actually go into some additional description here. The cull mode, culling is removing certain polygons. What we want in this case is going to be cull mode back bit. Okay, so it's VK cull mode back bit. And we're also going to do rasterizer front face, and it's going to be VK front face clockwise. Okay, so let me go into a little more explanation about that. Back bit right here says that we want what's called back face culling. And that means that the rasterizer culls any polygons that are facing away from the viewer. So you wouldn't be able to see these anyway. So, if you're looking at a character model, anything along the back of the character model, away from the camera, would be removed. It wouldn't have to render that because you can't see that anyway. It'll allow the rasterizer to only send the necessary polygons onward. Then the front face setting right here, that determines which side of the polygon is the front based upon the order of the vertices. So I actually have an example here. I'll show you guys. So this website right here, learnopengl.com, has some really good visuals to kind of explain it. The front face setting right here is the winding order for the polygons. So what that does is, based upon how the vertices are read in, it determines which side is the front, which side is the back. So in this case, clockwise for this triangle here would be 1, 2, 3, and counterclockwise would be 1, 3, 2. It's still starting on the same point, but the way it winds those vertices around determine which one is the face. So, for instance, if we were using clockwise, which we are, then anytime it reads the vertices as having been created in a clockwise order, then if it's viewing the vertices and they're counterclockwise, it knows that has to be the back. So, down here is a good example. I think in this case they're using counterclockwise, but you'll notice you have someone viewing these two triangles that would make up a larger polygon. It's a cube here. And on this side, it's going counterclockwise, and the vertices were created in counterclockwise order. So it knows that this must be the front. But because there's another triangle at the back here, but you're viewing it in the wrong order, you're seeing the vertices in a clockwise order when this was declared in counterclockwise, then the rasterizer can determine that this is the back of the polygon, and it can throw that out. So it's just a way of determining what's necessary and what isn't. So that's the gist of it. We're just declaring it clockwise for ours, and then it knows anytime it encounters something counterclockwise, it must be the back of our polygon. Alright, that was kind of lengthy. Hopefully that made sense. Moving on, we also need a rasterizer. Rasterizer. Dot depth bias enable. And we're going to set this to VK false. We're not doing anything with the depth. We don't care about that right now, so it's just much simpler that way. Alright, so next up we have a CreateInfo for multi-sampling. So multi-sampling is used for anti-aliasing, which if you're not familiar with that, it's when they smooth the jagged edges along a geometry. So if you've ever seen a video game and they look a little awkward around the edges, kind of pixely, that's when anti-aliasing is not being used. So, or isn't being used properly. We're not going to worry about this right now. It's more than we really need, but we still need to pass in the structs, so we're going to go ahead and set it up. It's just going to be a VK pipeline, multi-sample state CreateInfo. And I forgot I need to name that something. We'll call it multi-sampling. There we go. Alright, and then once again we need to have an S-type for it. And that one is going to be a VK structure type pipeline multi-sample state CreateInfo. There it is. And we're just going to set everything to false for now, so we don't need to worry about it. We can always come back to this later. So sample shading enable equals VK false, and multi-sampling dot rasterization samples equals VK sample count 1 bit. Okay, cool. That's all we need for the multi-sampling. Now we can finally move on to the color blending stage. So what happens here is that the colors that are passed from the rasterizer get combined with the colors that are already present in the frame buffer. So to set this up, we're actually going to need two different structs. The first one is a color blend attachment state. So it's VK pipeline. Oh, my brain shut off. There we go. VK pipeline color blend attachment state. We'll just call that color blend attachment. So this one, keep doing that. There we go. So this one is supposed to handle the color blending for a single frame buffer. Assuming that you have multiple ones to deal with, we're only going to be having the one frame buffer, so this is going to be a lot simpler. And normally this would handle the color blending by, mixing together the original color value and the new one being passed in. We're not going to worry about this too much for now, so we're just going to set the blend enable to false. So it's just color blend attachment color right mask equals, this one just has to be set up, so it's VK color component rbit. Okay, we're going to need 3 of these, so I'm just going to copy and paste. Be careful if you do it the same way I do. You don't want to discover you messed something up. So you need an R, you need a G, and you need a B. Red, green, and blue. It's pretty straightforward. And let me see, you also need an alphabet. So VK, oh, can't forget that. VK color component a bit. There we go. And then, like I said, we're just going to take color blend attachment, blend enable equals VK false. So, not worrying about that right now. Now, like I said, we need two different create infos. This second one is the color blend state. And this one is more of a global setting for all of the frame buffers. So this way, it would allow you to set like blend constants that can be factored into the blending that would take place in the color blend attachment that we just declared. We're not going to be doing this either. Lots of this stuff we're leaving out for now just because it simplifies things. So we're going to set everything to false again. So it's VK pipeline color blend state create info. Call it color blending. There we go. We need an S type again, and it's going to be a VK structure type pipeline color blend state create info. There we go. We're going to say color blending dot logic op enable equals VK false. We're going to say color blending dot attachment count equals 1, because we're just passing in the one color blend attachment from above, and then of course we need to pass in a reference to that. So color blending dot p attachments equals a reference to color blend attachment. Alright, that was a lot of code for something that's not really doing a lot right now, but it's important. Now we need to fill out the dynamic states. These are elements that can be changed later on without recreating the entire pipeline. So it allows us to affect things in the pipeline settings without just declaring a whole new one. So we're going to make an array of all the states that we might change. In this case, it's going to be the viewport and the line width. Let's go ahead and get that right in here. It's going to be VK dynamic state, and we'll just call it dynamic states, and it needs to be an array. And we're just going to go ahead and put VK dynamic state viewport. There we go. And VK dynamic state, and this is line width. There we go. Alright, and now we need to declare a dynamic state create info and set the count to the number of objects that are in that array. So we're just going to say VK pipeline dynamic state create info, call it dynamic state, and there we go. And just to clarify, this array is dynamic states plural. The create info is dynamic state singular, so be real careful there. Alright, so we need a dynamic state S type, which is going to be VK structure type pipeline dynamic state create info. Alright, and then dynamic state dot dynamic state count is going to equal 2, because we declared the 2 right up here. And then, just like everything else, we need to pass in a reference to the states. So we do p dynamic states equals dynamic states. There we go. So now that's getting a reference to the states that we declared. Alright, so besides the dynamic states, you can also create uniform variables in the shaders, which can be changed while you're drawing. It's similar to the dynamic states, something else that you can modify without recreating the pipeline. We're not going to be using this yet, but again, we do need to create the structure for it. And this one is actually a Vulkan object, so we're going to need to create a vdeleter for it. So let's pop over to our .h file. Come on, where is it? Here we go. And so just underneath swap chain image views, we're going to make another vdeleter, and it's going to be a vk pipeline layout. Pipeline layout, there it is. vk pipeline layout, call it pipeline layout, and we need to pass in, like usual, the logical device and a destroy function, which in this case is vk destroy pipeline layout. There we go. So now we have our pipeline layout variable. Pop back over to the CPP, and now we make CreateInfo for it. So it's going to be a vk pipeline layout CreateInfo. Call it pipeline layout info. And we need an S type, so pipeline layout info S type equals, it's vk structure type pipeline layout CreateInfo. There we go. And since this one is a Vulkan object, we now have to create a create function for it. So just like usual, we're going to do another if statement. If vk create pipeline layout, and we pass in the usual stuff, so logical device, reference to the pipeline layout, pipeline layout info, because you need to pass in the create info, null pointer for the p allocator, and then we call pipeline layout dot replace. Again, this is because we're using the vdeleter. Normally you wouldn't do it that way. And then we're just going to go ahead and say if it does not equal vk success. There we are. So if it fails, we need to throw an error like we do. So we're going to say throw std runtime error, and this is going to be failed to create pipeline layout. And if it succeeds, we want to know. So we'll go ahead and say cd cout pipeline layout created successfully. Alright, and that should be all we need. Let's give this a run and see if it works. Hopefully this won't take too long. Just give it a moment here. And let's see how we did. Come on, you can do it. Alright. Let's see, we can see everything running there. Let's move this out of the way. Alright, and there it is. Pipeline layout created successfully. And that's all there is to it. So, that is everything for our fixed function stages, and that's all there is for this episode. So, thanks for watching again, guys. I know this wasn't exactly the most exciting episode, but it was all necessary to get where we want. In the next episode, we're going to be setting up a render pass and then finally creating the graphics pipeline itself. We still won't have anything on screen. It's probably going to be a couple more episodes before that, but we're nearly there. There's just a little bit left to do. So, well done for getting this far, and see you in the next episode.